Hi class, so for the chapter 8 class 3 part 4 we're going to discuss about factors that change the SML. Case 1. If investors raise inflation expectations by 3%, what would happen to the SML? Risk-free rate is a nominal rate on U.S. Treasury securities, consisting of two elements: real inflation, real free rate of return, R star, and inflation premium, IP. Okay, we discussed about this before. Risk-free rate is typically the return on 3-month Treasury bill. It is R star, real risk-free rate, plus IP, inflation premium. Okay, here we're assuming investors raise inflation expectation by 3%. Okay, which means IP here will increase by 3%. So our risk-free rate will increase by 3%. Okay, so our SML would change from RI equals 5.5% plus 5% multiplied by beta to our new SML, SML2, RI equals 8.5% plus 5% multiplied by beta. Okay, because our risk-free rate here increases for 3%. So it goes up from 5% to 8.5%. Okay, so you can see our SML line is moved up parallelly. Okay, our intercept with RI y-axis, when beta is 0, RI used to be equal to RF, which is 5.5 for SML1. Now it equals to 8.5% for SML2. Okay, so SML moved up. And with beta is 1 for market portfolio, okay, the RM moves up from 10.5% to 13.5%. Okay, so RI goes up for 3% when our IP goes up for 3%. Okay, because our risk-free rate goes up for 5%. Case 2. If investors' risk aversion increased, causing the market risk premium to increase by 3%, what happens to SML? So we've discussed about risk aversion assumption of investors, that investors hate risk, right? So that's why we need additional risk premium when we are buying risky assets. Okay, so if risk aversion degree increased, okay, and our market risk premium, RM minus RF, increases by 3%, the slope of the SML would reflect this change in risk aversion degree. Okay, the steeper the slope of the line, the greater the risk aversion, the more the average investor requires as compensation for bearing risk. If there were no risk aversion, there would be no risk premium. In that case, the SML would be a horizontal line. Okay, so if we look at the equation here, okay, used to be RI equals 5.5 plus 5% multiplied by beta. Now this coefficient on the beta, market risk premium, goes up to 8%. Okay, so this line moves up, but this time it is just the slope that goes up. The intersection with the y-axis with RI. When beta is 0, RI is still 5.5%. Okay, this point doesn't change. It's just the slope that increased when market risk premium increases by 3%. When beta is 1, RM also goes up to 13.5%. Okay, so this is the second change on the SML. Okay, when investors become more risk averse, the slope of the line goes up when market risk premium goes up. Okay, so that's the two change on SML. Verifying CAPM empirically. The model we've discussed to measure stock return, it has not been verified completely. Statistical tests have problems that make verification almost impossible. Some argue that there are additional risk factors other than the market risk premium that must be considered. So here we have only one factor, which is market risk premium, considered in our model, but there are also 3-factor model, 5-factor model, including other risk factors, okay, including other risk premiums. Remember, for bond, we not only have DRP, LP, we have MRP, we have different risk premiums for the bond. Here, for the stock return, we actually only have market risk premium, only one risk premium in our current model, okay, but as a matter of fact, in the literature, there are a lot of other factors added to this model. For example, SMB, the size factor, small minus big. High HML, high minus low, the growth factor. Okay, if you're interested in these other factors, you can Google search or you can read some related academic papers. More thoughts on the CAPM model. Investors seem to be concerned with both market risk and total risk. Therefore, the SML may not produce a correct estimate of RI. Okay, so again, there could be other risk factors besides this market risk premium here. CAPM or SML concepts are based upon expectations, but betas are calculated using historical data. A company's historical data may not reflect investors' expectations about future riskiness. Okay, remember we calculate beta based on historical data, and then we use the estimate beta to predict future stock return. Okay, but so we're actually predicting future return based on what happens in the past. So it could be not that accurate. Okay, so here are all the discussion on the CAPM. Let's look at a practice here. This practice is actually related to Chapter 8, Class 2. Okay, we know a 2-stock portfolio here equally invested in collectibles and US rubber. And we know the expected returns of these 2 stocks in each economy scenario for 5 economy status. We know the probability of each scenario. What is this portfolio's expected return, standard deviation, and coefficient variation? Okay, so to find the return of the portfolio under these 5 different scenarios, we can use two methods. Okay, I listed 2 methods here. The first method is to find the expected return for each stock first. Okay, for collectible, it is 1%, and for US rubber, it is 9.8%. Okay, and we can find expected return for each stock by using the 5 probabilities multiplied by the 5 returns in each economy scenario. Okay, for collectibles, we use 0.1 multiplied by 27% plus 0.2 multiplied by 13%, 0.4 multiplied by 0%. Okay, do it 5 times as listed here in this equation. We can get this expected return for collectibles as 1%. For US rubber, we can use these 5 probabilities multiplied by these 5 returns. Again, we can have this 9.8% as expected return for US rubber. Okay, so we can have expected returns for the 2 stocks first. And then we can have the portfolio's expected return as the 2 weights for the 2 assets multiplied by the 2 expected returns for the 2 assets. Okay, weighted average of the expected returns of the stocks in the portfolio. So we use 50% multiplied by this 1% plus 50% multiplied by this 9.8%. So we can have 5.4%. Okay, that's the first method of how we calculate portfolio return. We can calculate expected return for the 2 stocks first and then take the weighted average. to calculate the portfolio return. Our method 2 is to calculate portfolio return in each economy scenario, okay, by taking the weighted average. When economy is in recession, we can use 50% multiplied by 27% plus 6% multiplied by 50%. So we have this 16.5%. Okay, and we do the same thing for the other economy scenario. So we have portfolio return in the 5 scenarios. And then we can use these 5 returns multiplied by the 5 probabilities. So we have portfolio return as 5.4%. Okay, this is the second way of getting portfolio return. Okay, same as the first method. The first method is to calculate expected return for the 2 stocks first and take the weighted average. The second method is to calculate portfolio return in 5 economy scenarios first by taking the weighted average of the 2 stocks, and then calculate portfolio return by using 5 probabilities multiplied by the 5 portfolio returns. Okay, if we want portfolio standard deviation and coefficient variation, we can use the 5 portfolio returns minus the expected return, okay, square it, and then multiply by the 5 returns, okay, as you can see here, and take the square root. So we have 6.68%. For coefficient variation, we can use this sigma standard deviation of portfolio divided by expected return. Okay, so we have 1.237 as our coefficient variation. You can also use the calculator to get expected return and standard deviation after getting portfolio return in each economy scenario. Okay, so we can input in data function in the financial calculator. And for x, we input the 5 returns. Okay, the 5 returns for the economy return, but we remove the percentage sign. Okay, for y, we input the 5 probabilities. 5 probabilities multiplied by 100. Okay, so it becomes, so 0.1 becomes 10. Okay, 0.2 becomes 20, 40, 20, 10. Okay, we input these and we go to stats function. We calculate x bar and sigma x. Okay, remember we go to stats function. We make sure n equals to 100. We press down button, so we see x bar. Okay, that's expected return of the portfolio. We press down button twice and we see sigma x. Okay, I think I also showed here. Okay, so that's for portfolio return and standard deviation. We can use financial calculator. If you want to figure out what is the expected return for the 2 stocks, you can also input x. You can also input the 5 returns for collectibles multiplied by 100 as x, and 5 probabilities multiplied by 100 as y, and calculate expected return and standard deviation for collectibles. For US rubber, you can input x as return for US rubber multiplied by 100. Okay, and for y, you input all the 5 probabilities, and you can calculate expected return and standard deviation for US rubber. Okay, and here again for a portfolio, you can do the same thing. For x, you input portfolio return multiplied by 100. For y, you input probabilities multiplied by 100. So you have portfolio return and standard deviation from the financial calculator. Okay, so this practice is actually a review for Chapter 8, Class 2. Okay, if you're not sure how to do these, you can refer back to our Chapter 8, Class 2 notes. Alright, so this is all for Chapter 8, Class 3, and this is all for actually Chapter 8. You can start to work on Chapter 8 homework now, and because our spring break has been extended for a week, so I have also extended the deadline for Chapter 8 homework for a week. Okay. And I'll see you in next video to start with Chapter 9.